Hello everyone, I am Bhavyashree from second year ECE department and my roll number is 24BQ1A0439. So my seminar topics are impulse response and step response. So we are going to know about impulse response. So first of all, what is impulse response? Let us consider a system which is having input as unit impulse signal. Then we get output as impulse response. So it is usually denoted as h of t for continuous and h of n for discrete. So in derivating that, for continuous time it is del of t is equal to infinity for t is equal to 0 and 0 for t is not is equal to 0 with integral minus infinity to infinity del of t dt is equal to 1, and for discrete it is del of n is equal to 1 for n is equal to 0 and 0 for n is not is equal to 0. So what is the importance of impulse response? So here it is, the impulse response characterizes a linear time invariant system, which is LTI system. So once we know h of t or h of n, the response of any arbitrary input can be computed using convolution. So first of all, if we find h of t or h of n, we can easily calculate the convolution. So for continuous it is y of t is equal to x of t convolution h of t, which is nothing but integration minus infinity to infinity x of tau into h of t minus tau d tau. And for continuous we derived, and for discrete it is y of n is equal to x of n convolution h of n, which is nothing but sigma k is equal to minus infinity to infinity x of k into h of n minus k. So if we consider an example, y of n is equal to x of n plus x of n minus 1. So at n is equal to 0, by substituting n is equal to 0 we can get 1, and for n is equal to 1 we can get 1. For other n, y of n is equal to 0. So we get h of n is equal to 1 comma 1. And what is step response? So previously we told that if we give input as impulse signal we can get impulse response. So here also if we give input as unit step signal we can get step response. So here it is denoted as s of t for continuous and s of n for discrete. So s of t is equal to system response to u of t, s of n is equal to system response to u of n. So unit step signal for continuous it is u of t is equal to 1 for t greater than or equal to 0 and 0 for t less than 0. And for similarly u of n is equal to 1 for n is greater than or is equal to 0 and 0 for n less than 0. So what is the relationship to impulse response? So if we derivate the step response we can get impulse response. So in that case, if we integrate the impulse signal then we get unit response and step response. So therefore the step response is the cumulative sum of the impulse response. As we get for continuous, s of t is equal to integral minus infinity to t h of tau into d tau, and for s of n which is equal to k is equal to minus infinity to n into h of k. So we can conclude that impulse response, it describes about instantaneous reactions. So for step response, it describes long term system behavior when input switches on and stays constant. So if we get an example, if we consider an example, y of n is equal to x of n plus x of n minus 1. Initially we already found that h of n is equal to 1 comma 1 in the example of impulse response. So similarly, for s of n is equal to sigma k is equal to 0 to n h of k. At n is equal to 1, s of 1 is equal to h of 0 plus h of 1, which is equal to 1 plus 1, which gives us 2. So at n is greater than or is equal to 0, it gives 2 only. Thank you.